Hi, we're Entropin. I'm Nathan, and this is my co-founder David. I'm a current junior at UC Berkeley studying chemical engineering and computer science. Most of my experience revolves around the intersection of chemical engineering and machine learning. An example is my research, in which I apply machine learning to empower the predictive control of chemical systems or discovering catalysts for breaking down CO2 into renewable energy. My experience also includes the machine learning project I did in the industry for emissions, in which, with over 12,000 devices implemented worldwide, we were able to cut down the nitroxide emissions by around 12%. That's like 1,300 tons. I've also worked at a VC as a technical consultant and informed over seven-figure US dollar investment decision.
Yeah. Hi, my name is David. I'm a chemical engineering major and X major at Berkeley, a third year. And I'm working at a few labs right now, and all of them I'm using machine learning to accelerate their research. One of the research labs I'm working on there is Omar Yagi, who recently won the Nobel Prize in chemistry. So I'm using machine learning for researches in carbon capture for MOF and electric aviations, and also a materials project, which you have 620K users use around scientists around the world. And not only that, I also have experience in project manager at Logitech, leading a project, and also Union Schmidt Belch, which is a big pharmaceutical companies in Europe. And to elaborate a little bit more on our employees that we are managing right now, we have people experienced in process simulations and process designs, and we have people working on research on policies and other business outreaches, and as well as website.
Yeah, so as you can see, Entropin is a team synergizing cutting edge chemical engineering research and machine learning applications, making us the perfect fit for solving the problem we're trying to address. And the problem being, to give some context, in the current industry, a lot of companies spend significant amounts of resources trying to optimize their pipeline, whether it be increasing manufacturing yield or decreasing energy consumption. However, lots of smaller companies, especially in the growing industries, don't have the resources to do that, whether it be money or like data, which is why Entropin is trying to develop a pipeline. It's a co-pilot for R&D engineers that, empowered by physics-informed machine learning model, to introduce inexpensive, universally applicable, and low-risk optimization methods that can be used for those smaller companies.
There are actually a few more advantages when it comes to our solution. First of all, we are able to operate with much less data compared to other competitors. So, for example, if we are targeting very small industries like and growing industries like carbon capture storage, it will be a perfect fit for them. And not only that, we're much cheaper to implement because we're not hardware solutions, but more a software solution. And we are able to scale beyond carbon capture and storage and pulp and paper, cement, food and pharmaceuticals, and all those manufacturing related roles. And lastly, we talked with process engineers from Boeing, Chevron, P&G, and Shell. And what they've been telling us in Unity was that current solutions like Aspen, Honeywell, and Aviva, they do not focus on smaller industries and they don't really focus on heat. And not only that, they're not really building PINN, but they're only using linear regression.